Okay, in this video, we're going to talk about and do a little review of inheritance. So I assume you've seen this somewhere before, but if not, it's okay. Okay, so we're going to start looking at the UML diagram on how we show inheritance in a UML diagram. Okay, so the last video, we talked about the UML diagram, how that's useful to allow us to show what the class is going to contain. Okay, so I'm going to go ahead and do that for this example. Okay, I don't think this works. Okay, there we go. It's always something. Okay, so the basic way this works. So we've talked before. You have a basic UML class diagram. Here you have the name. Here you have the member data. And here you have the functions. Again, this is what the class knows, and this is what it can do. Okay. So for inheritance, we're going to put in these black diamonds here to another class, okay, which looks just like that. Okay. This black diamond inheritance is called an is-a relationship. Okay, so whatever this box at the bottom is whatever this is. Okay, and with inheritance, the member data here is visible here, and the functions here are visible there. Okay, we call this a specialization. So here's the example we're going to do. If we have an employee class, for example, okay, and that employee class, it may have a name, which is private, which is a string, and it may have a department. I'll abbreviate here, but I won't in the code, which is a string, okay? And it may have its, accessors and mutators, whatever functions it has, okay? To specialize this and add more information to it, in some cases, I can come over and do a salaried, okay? So a salaried has access, so it has a name, it has a department. The way we get to it may not be as clear as we would like, but we can get to it, okay? Let's say I'm going to add, in this case, a salary, okay, which takes a float for that salary, okay? And then I would have an accessor and a mutator for it. The public functions have to deal with the constructor, okay? And then over here, I could also have another one for an hourly that will add a rate, which is a float. Okay, and that's what that should look like. Salary colon float. Okay. And then add the functions that I want to add down there, including a constructor. Okay. So again, we say a salaried employee is a employee, and an hourly employee is also a employee. Okay, so that's kind of how we would put those together. Okay. The other kind of inheritance, we'll mention this briefly, and we may talk about later. I'm not sure that we do actually. It's called composition. And it is a has-a relationship. Okay, so you could have, for example, a car class. And I think we put an open triangle, it seems like, I could be wrong, that it has an engine and it has wheels, whatever it has, okay? So composition is a has-a relationship, okay? But the example we're going to do is going to be this is a relationship with employees that can be either salaried or hourly, okay? So let me shut this down and we'll switch over, stop the share. Okay, in fact, I can get rid of that, don't need it. Okay, and now I'm going to share my screen with the terminal window. Okay, so again, this assumes right now that I've logged in to the terminal, however you get there, to the Linux machine. And remember, I have created, I'm in my home directory, okay? A CD tilde always gets you home in case you need to do that. I can CD into the CSC 2180, which is the example directory we're doing, okay? In this case, we're going to go into the chapter 2 directory, okay? we see that there's nothing there. Okay, so I'm going to go ahead and start creating this. I'm going to create this employee.cpp. Okay, so let me say that there normally you're going to create a class in its own file and then test it in a separate file using a header and all that stuff. Okay, that's the more normal way to do it. But in an effort to streamline the videos and make them shorter and to make it easier for us to have fewer working parts in essence, this time we're just going to create everything, including the test program and all of the subclasses and parents and children, all that in one file. Okay, so because of that, I have to go ahead and include my IO stream. I have to put my using namespace standard here as well. Okay. Okay. And it may not be a bad idea to put my int main up here at the beginning, just so when I'm looking for it, it's easier to get to. We won't have it do anything except return a 0. Okay, but that should still compile. I don't think it'll give us any trouble. Okay, although I'm not sure I can put it there actually. I think let's not do that. Let's be on the safe side. Let's go do our classes first, because the classes have to be there, I think, before it'll run things. Okay, so let's not take a chance. We'll have to go to the bottom to do this. Okay, so let's do a class employee first. Okay, just like we did before. In our private section, we're going to have a string for the name, and we're going to have a string for the department. Okay, that's all we have there. Under public, I'm going to go through and make my list. I want my accessors. I want my mutators. Other functions we may need, and my constructors. And destructors. Okay. Again, programming should be ritual. Okay, this is the ritual we're gonna go through just so we know not to forget stuff. Okay. While I'm here, I'm gonna go ahead and end this because I'm gonna have multiple classes. I'm gonna say I'm gonna end employee. If I double the right letter, class. Okay. So that's done there. Okay. So accessors, all accessors will look more or less the same. Okay. So in this case, it returns a string. We have get name, takes no parameters, does nothing but return name. Another string, get department. Does nothing but return department. Mutators, both of these could have mutators, but again, for brevity, we're just going to go ahead and do a set department. People certainly do change their name, but we're just going to do it this way. And again, I like to keep things simple. Again, that whole idea of a ritual. When I have a variable that I'm going to set to department, I'm just going to name it D here. I can name it department and then do something like this department is equal to department, but that I think that gets needlessly confusing. So in this case, I know what I'm sending in. I'm just going to set department equal to D, and I'm done. Okay, that's all I need. Okay. The other we can come back to in a second, but let's go ahead and do the constructor next. Okay, so we have an employee. The constructor has no return type, has the same name as the class. It's going to have a string N for name and a string D for department. And this is going to set name is equal to N and department equal to D. That's all we're doing. Okay, easy enough, straightforward enough. Down here, we can go ahead and test this by saying employee E1, which will be our friend Bob. Bob works in accounting. Okay, that's all we can do with it. Okay, so let's do that. Compile it here. -O to employee.exe. There we go. /employee.exe. We didn't ask it to do anything, but it doesn't do anything. Okay. And just to review how this works, I'm hidden from, or I'm blocked from direct access. So I can't say cout e1.name. Okay. If I do that, it should give me a privacy warning, which it does. It's declared private. It shows me the line it's declared on. Okay. But I can, that's why we do the accessors. Again, just reviewing that. I can do an e1.get name. Okay. And that works. Okay. So just so we're clear on why we're doing it. Okay. In fact, let's go ahead and add our other function now that we know that's working. I'm going to do a void print function. Again, I said it in the last video. I'll probably say it a lot. A function shouldn't print unless it does nothing but print. And this is going to do nothing but print. Okay. So this one's just going to be a nice little way to print out the contents or an instance of an employee class. Okay. So in this case, we're going to cout, kind of what I did before, put a couple of new line characters and say name. Okay. Since department's much longer, I'm going to put in 2 tabs to try to get things to line up correctly. They may not still, we'll have to see. Okay, and then I'm going to do name and an end line. Then I'm going to cout department. Again, the slash ends are new lines, slash t's are tabs. Hopefully I can just do 1 tab there. I'm going to do 2 endls there. Okay, and endl is just a shortcut for a single quote backslash n single quote. So you can do either one. Okay, but this seems easier to do. Okay. Going to end that one. So now down here, I should be able to say, instead of all this stuff, just say e1.print. Okay, make sure that all works. All looks good. Compile it, run it. There we go. Bob works in accounting. And the number of tabs was correct. If I only had 1 tab after name, Bob would have been over to the left more than accounting would be. Okay. So now let's think back at our UML diagram, and we want to add an employee, sorry, a salaried class, and we want to add an hourly class. Okay. So I'm going to go beyond this one here, and I'm going to say a class salaried. Okay. And the colon here is going to show the inheritance. It's going to say that it's inheriting from, okay, employee. A couple of options. There's public and there's private. Okay, private restricts what you can do with the variables that come in. So we're typically, unless there's a good reason, we're going to do a public. So this is saying this is my new class salaried that inherits in a public way from the employee class that must be defined above. Okay, you got all that, so that's good. Okay, so just like before, we have a private section. All we're adding this time is going to be a float called salary. Okay, we then have a public section. Okay, again, every time accessors, mutators, other, constructors, and destructors. And all that should be there. Then I'm going to go ahead here. Oh, there we go. And salaried class. Okay. So we're going to make one more after this. So while I'm here, I'm going to go ahead and copy this. Again, we don't cut and paste, we kill and yank. So Control K to get all of this out of the way. Control Y to yank it back, Control Y again. We'll get to that in a minute for, in fact, to avoid confusing ourselves. Let's go ahead and change this to hourly. The way you do this is up to you. We put an hourly rate here, only if I get the letters in correctly. Okay, then this will be called, no, that's it. Oh, the end will be in hourly. Okay. So again, they're specializing that the employee class is specialized into salaried employees, which add a salary, and hourly employees, which add an hourly rate. Okay. So in the salaried class for my accessors, I'm going to have a float for get salary. Okay, these are all pretty basic. That's nothing but return salary. Okay. The mutators are always void functions on a set salary, okay, which takes a float S for salary, like I always do. This is a good reason, okay. Now I am just going to violate one of my golden rules. I'm going to trust the user to put in a reasonable salary, okay. You probably shouldn't do that, but to make the videos shorter, to make it simpler, okay. Don't really do this, but we're going to do that, okay. The constructors, we've got some work to do here, okay. The constructor here for the salary, we can't directly get to the name and the department, okay. So we're going to have to call the base class constructor. It's still going to be called salary because with no return time, okay. But this time we're going to have a string for the name, a string for the department, and a float for the salary, okay. So we need all three of those bits of information, okay. We can't directly access either the name or the department, okay. So we're going to have to call the base class constructor, which is just called employee, with that N and D, okay. So this is saying create a new salary that has a name, a department, and a salary. But for the name and the department part, I'm gonna have to call up to the base class to do that. That can do that, that works. Then down here again, I should check it. I'm just gonna let salary equal to S. Okay, that's gonna take care of that one, okay. While we're here, before we test, normally I wanna test it before I do anything else, but I've already got the hourly in there, so let's go ahead and do this one. Okay, very similarly, we're going to have our get rate, okay, function, which returns, I forgot that, a float. No parameters. We return a rate. Okay. For our mutators, again, we're going to be trusting, which we shouldn't do. It's a void function, set rate, which is going to take a float R for rate. Okay, it's going to set rate is equal to R. Okay. Then here for the constructors, again, we have the hourly constructor, which is going to take a string for the name, a string for the department, and a float for the rate. Okay. And again, it has to call the base class employee with the name and the department. Okay. The only work it has left to do is to set the rate equal to R. Okay. So that's our hourly class. So now in our main, we're already adding just a generic employee. So now let's do a salaried, sorry, E2, which is going to take, let's see, we'll call this E2 person, call her Alice, normally what we do here. So we have Alice here. Let's say Alice works in the programming. Okay, and Alice has a salary of $60,000. Okay, all that's got to be put there when we're creating it. Okay, because Alice is an employee, in addition to being a salaried, I should be able to say e2.print. That should be good. Okay, let's go ahead and do an hourly E3. Let's call this one Ted. Let's say Ted is in maintenance. Maintenance. There's too many letters in that. Who knows if that's correct? Spelling sometimes leaves me, especially when I'm programming, my brain's in a different area. Okay, we'll call it that. That'll be good enough. Okay, all we have to add is hourly rate. So he makes $15 an hour. Okay. And again, since Ted is an employee, we should be able to do a print on that function. Okay, so see if we've got it all working here. We do not. What doesn't it not like? Okay. It has an issue on line 63 first. Let's take a look, see what I've done. Again, a control V and Emacs will take me down a bunch of lines at a time. Probably, is that where the issue is? So that ends the mutator. There's a float S, salary equal S. I don't know what its issue is there. Did I set, yeah, float salary. Spelled the same way. If it's something down here that I didn't change. Seems okay. Not sure what it's doing. Let me try it again. See what it's doing here. Okay. On line 63, in this line, forbids declaration of salary with no type. But it has a type. So what have I done wrong? Let me check the code here to see what I'm doing. Go back into the code. And I would normally stop the video, but you need to see me find these errors. Nothing wrong with that. Gonna make sure it's not somewhere other than what I think it is. Okay. So I start off here with the salaried. Okay. Make sure it's all looking correct. We've got the float on the salary. Okay, it should be okay. Okay, and that's the private. And then the public, we should have a float get salary, which is going to return salary. Okay. And then we have a mutator, void set salary, which is a float S, salary equal S. It's all happy with that. Okay. So then it goes down. That ends. And it goes to the constructor. Salary has a string N, a string D, a float S, and then an employee with ND. Yeah, I don't know. Super strange. Makes me also think let me try it. Sometimes you type it again, it makes a difference. So let's, there's our float S. We're in the, oh, here's the issue. It's not the salary class, it's the salaried class. Glad I saw that. It could have been the rest of my life on that one. Okay, let's try it now. Make sure I've done the other one correctly as well. It doesn't sound as weird, so it's out. Yeah, that should be okay. That's what it's doing. Okay, now we're good. Now we run it. Yeah, so now we've got Bob in accounting, we've got Alice in programming, we've got Ted in maintenance. Okay, so we're good. Okay. One thing we may want to do. So let's talk some more about some of the features of the inheritance. Okay, the object-oriented programming. We may want a different version of print. It'd be nice to have the salary print on a salaried employee or the hourly rate on an hourly employee. Okay. So we can do that. We can overload those. Okay, so all we have to do is go into the proper function here. So we've got the name of the department already. Okay, so I can go ahead, nothing wrong with this. I can copy this or kill it and yank it. Okay, I'm going to do the same or put the same one in the other section. Again, because I put my titles in here, I already know where it goes. I'm going to yank there. I'm going to come on down to hourly, into other, yank there as well. Okay. So up here in salaried, I'm just going to go ahead and I'm going to get rid of actually one of these indels. Don't want an extra one there. Do a C out. Salary. I don't know if we had 1 or 2 tabs. Let's try 2. See what that looks like. See what this does. Okay, see if this works. Okay, and again, it's going to call if there's a local version. If salaried has a version of print, it's going to call that. If not, it's going to look to see if there's one in the superclass, in the derived class, or the base class, sorry, in employee. It's going to run it there, okay? See if this works. I have bad feelings about it. Oh yeah, there's a problem. Okay. The problem is in salaried, in that print function in salaried, we have the name and the department are private. Can't get to them directly, okay? So we're going to have to run these functions, the get name, the get department. Okay, shouldn't be a big deal. We can do that. Okay, but we're not attached to, we're not in a main program where we can refer to the object. Okay, but remember, there's a this keyword. This is a pointer to the object that called the function. Okay, so I'm now in my salaried. I can say this. I do a dash greater than, and then do a get name, and that's a function. In the same way, I can do a this dash greater than get department, which is a function. It'll give me the same error message in this copied thing I have down here. So let me go ahead and fix that while we're at it. Okay, so here I have to do this get name. I have to do the same thing here. This get department. Again, the this is referring to whichever object called this function. It's a pointer. We'll talk more about pointers in the next video. Okay, it points to that object. Okay, so in the case salaried was E2, so it'll be E2. So it's really saying an E2 print. Okay, or an E2 get name and an E2 get department. Okay, that's how that should work. Okay. While we're here, before we fix this or run it again, let's go ahead and fix this last name, getting rid of one of the indels. Then we're going to down here do a C out. Rate. I'm sure that will need at least 2 of those. I can just print out rate. It's okay. And then 2 indels. Okay, should be good. Okay. So then our test program here, we're going to do all 3 of those, print them all out, see what we get. Okay. Any other mistakes? Nope, we're good. At least we don't have any syntax errors. There we go. So we're now getting the proper ones. Okay. Bob prints out from the employee print. Okay. Alice is printing out from the salary print, so it prints a salary. And then Ted is printing out from the hourly. Okay. We could have made this prettier. Our functions or our numbers don't print that great, but it gives us the idea. Okay. So let's think about another issue here. And this is jumping ahead a little bit. This is not to the next video normally, but I want to talk about the idea of virtual functions. Okay. And abstract functions. Okay. it may be the case, I think one could argue, depending on the situation, certainly, that you never want just an employee. Okay, every employee should be either an hourly employee or a salaried employee or a part-time employee or whatever categories you have. Okay, so if we want to keep a class from being instantiated, we have to make it an abstract class. The way we make it an abstract class is by creating a pure virtual function in that class. Okay, a lot of words I have to do at you. So let's take an example. Okay, so in our employee class, we have this print function. Okay, if I were to make this a virtual, okay, and then say equals 0, it's the weird way we do things in that. Okay, by saying that, it is going to guarantee that it does two things. Okay, so let me do two things that it does. Okay, the first thing that this pure virtual function does, you have to spell virtual correctly though. Make it purple or magenta, whatever it is. Okay, the first thing this does is it creates an obligation in any child of employee to have a print function that is a void print function. Okay, with the same number of parameters. In this case, it's none. Okay, if we don't have that, it's going to give us an error. Okay, it also means that we cannot make an instance of an employee class. Okay, so let's test the first one. So we have now, we're creating Bob, our first person we create down here, as an employee. Okay, changing that to a virtual function means that should blow up. Okay, and that's what it does here. Okay, cannot declare a variable to be of an abstract type. Employee is now an abstract type because it has a pure virtual function. Okay, the pure virtual is the equal 0. Okay, part on the virtual. Okay, and it tells us that function is a pure virtual function. Okay, so we know now we have to get rid of Bob. Sad for Bob. We would actually just have to turn Bob into something else. So I could do Bob as a salaried, and that'd be okay. I would have to add in a salary for Bob. And now we should be okay. Now we're okay. Bob's now a salaried person. Okay, that works. But let's look at the other part of that, the obligation part. Okay. Let's say for some reason that we're going to go down into our salaried function. And we're going to take out this print function. That's using the multi-line comment with the / ****. Okay. Now if I try to run this, it's going to give me an error. Okay. Gives me an error. Okay. It's giving me all kinds of errors. It's giving me odd errors. Oh, because I can't do a salary either time. Okay. Because salaried doesn't have its own version of the print function, it's defaulting to the pure virtual function of the parent employee class, which means that it's an abstract class and you can't instantiate it. Okay, so I have to have that there. So if I go back, I can return my print function. Okay, the tab will put it back in the right spot. And now life should be good. Okay. So a lot going on here. Okay, so we're going to use inheritance a lot. We're going to use this idea of abstract data classes or abstract functions or abstract classes a lot. And what it's trying to do really is separate the details of the implementation from the idea. Okay. In this case, we're using the employee class as a way to pre-structure and give some conformity to the hourly and the salaried class. We could have just created an hourly and a salaried class separately, but then we couldn't have shared any code and we would have to work harder to make them behave in the same way. There's probably a lot of other data that there really would be in these files that are all going to be the same. Okay, so by putting in the structure, putting in the super class, or putting in the base class that they derive from, it allows us to enforce uniformity across the classes that we're creating. Okay, so hopefully that makes sense. If not, let me know.